Today we are going to be working on solving systems by elimination day number 4. Our content objective is students will be able to solve systems of equations by, of course, elimination. Language objective is students will be able to explain how to eliminate a term to solve for a variable. And last but not least, why am I learning this? Well, it's important for real-life problems like how many of each shirt or pants you can purchase with a specified budget. First, we're going to go over some background knowledge here in order to eliminate a variable, you want to find the lowest common multiple. So in this case, if I want to get rid of the x's, the lowest common multiple between a 2 and an invisible 1 here would be a 2. So one would have to be positive, another one would have to be negative, hence me multiplying by negative 2. The property that allows me to do this is called the multiplication property of equality. So here, the first one stays the same. The second one will change by negative 2, stripping to each term. The x's cancel out, leaving with 11y equals negative 22. Solve for y, plug it back into one of the original equations, and solve for the other variable. And then, of course, you would state your solution, but you don't know for sure until you, of course, check your answer. Okay, so now let's take a look at this one. How is this system different from all the problems we have solved so far using elimination? Well, I'm not sure if you noticed this, but both of these equations are not in standard form. Okay, normally we use elimination when the equations are in standard form. So in this case, I'm going to have to adjust this second equation because the first one's already in standard form. Quick reminder, standard form is ax plus by equals c. So in other words, a and x are on the same side and the constant's on the other side. So here, it's not in standard form because y is on the right side. We need to move it over to the left. So what we're going to have to do is go ahead and change it so that it is in standard form so that we can go ahead and try to eliminate a variable. So to use the elimination method, both equations must be in standard form. So we're going to work on that. Here, the first one's already in standard form, so that one's good. So we're going to keep that. The second one, we're going to have to move this 3y over to the left. So I'm going to go ahead and subtract 3y from both sides. It will cancel out here, leaving me with, and you want to be careful, you want to do x first, y second. So you're going to keep negative x first minus 3y second equals a negative 5. Then from there, you can go ahead and work on eliminating your variable. Okay, so now for number 1, it says here to set up the problem to be solved using elimination. So hopefully you recall from the previous slide, before I can go ahead and start using the elimination method to solve my system, I need to make sure that both equations are in standard form. And again, standard form is when, when ax plus by equals c. So in other words, a and x are on the same side and the constant is on the other side, opposite side of the equation. So here the first one is not in standard form. So what I'm going to do is go ahead and move the x over. So first I'm going to write it down, y equals 3x plus 4. So I'm going to have to move this over to the left. So I'm going to subtract 3x from both sides, which is going to leave me with, and remember you want to keep the x's first. So we're going to write the negative 3x, then you can put plus y, this will go away, equals 4. The second equation is fine, so I'm just going to go ahead and write it right underneath. So I'm going to put 2x minus y equals 5. So that's it. That's all I'm asked to do. I'm just asked to set it up. I'm not actually going to solve. So that would be enough for me to go ahead and start solving. Okay, so now I would like you to go ahead and try number 2 on your own. How would you set up the problem? So let's see how well you did. Hopefully you remember, in order for us to use the elimination method to solve this system, we need to make sure both equations are in standard form. Unfortunately, none of these equations are in standard form because it basically looks like this, where both x and y are on the same side and the constant is on the opposite side. So for the first one, it's not in standard form, so let's go ahead and fix that. First, I'm writing down the problem. I need to move the y over to the left, so I'm going to subtract 6y from both sides. So that's going to leave me with, again, you always want to write x first, so we have 6x minus 6y equals negative 72. Now let's go ahead and adjust this second one. We have negative 23 plus x equals negative 6y. So this one, yet again, I need to move my y's over to the left because I want x and y to be on the same side. I'm going to add 6y to both sides. It's going to cancel out here. Again, I want to keep in mind, I want to try to write my x's first. So I'm going to write x, the y's come next, plus 6y, minus 23. On this side, you're going to notice there's nothing left, so I'm just going to write 0, because the negative 6y plus 6y is 0. Almost there, we just need to add 23 to both sides. And my new equation would then be, it's going to cancel out, x plus 6y equals 23. Now we have a system that we can work with to use elimination on, since they are both in standard form. Okay, so now moving on. For this problem here, what we're going to do is, since we are using the elimination method, we need to make sure that both equations are in standard form. The first one's ready to go because x and y are on the same side and the constant is on the opposite side. However, the second equation is not. So since the first one's ready to go, I'm going to go ahead and write it down. Negative 2x plus 8y equals negative 10. Now for this equation, I am going to have to move the 6x over, so I'm going to subtract 6x from both sides. I do want to keep in mind I want to write the x's first, so I'm going to put negative 6x plus 18y equals a negative 36. So notice I wanted to make sure that the x's lined up, and so did the y's. Now it's just a matter of choosing what to multiply to get rid of the x's or the y's. Here, I think it'd be easier to go ahead and eliminate the x's. So I'm going to say the lowest common multiple between a 2 and a 6 is 6. So here, I'm going to have to change the first equation. In order to make 2 into a 6, I'm going to multiply it by 3. Excuse me. However, since both of these are negatives, I need to make one positive. So let's go ahead and make this 3 a negative. And now I'm going to change my equation to a positive 6x to a negative 24y equals a positive 30. Now this equation is going to stay exactly the same, so I'm going to put negative 6x plus 18y equals negative 36. So here there are definitely more negatives, so I'm going to put minus or negative. Let's see how many, I would say 6y equals a negative 6. So again, keep asking yourself, are there more negatives or are there more positives? Because there's nothing worse than getting it wrong because you forgot your negative. Divide both sides by a negative 6. The negatives cancel each other out, and so does 6's. So here y equals 1. But we're not done. We're going to have to plug that into one of the originals. I'm going to go ahead and pick the first one here. So we have a negative 2x plus 8y equals negative 10. I'm going to go ahead and plug in this y in for just the y. So I'm going to get negative 2x plus 8 times 1 equals negative 10. Leaving me with negative 2x plus 8 equals negative 10. Subtract 8 from both sides, and I'm left with negative 2x equals negative 18. I'm not done. I'm going to divide both sides by negative 2, and I'm left with x equals, the negatives cancel out, positive 9. So here I'm going to say that I think the solution is 9, 1. And the reason why I say I think is because, of course, I still need to check my work. So let's go ahead and quickly check the work. The x's are 9s and the y's are 1s. Writing down the equation first, negative 2x plus 8y equals negative 10, where the x's are 9s and the y's are 1s. Now we're going to simplify. We have negative 18 plus 8 equals negative 10. Is this true? Yes, so it works for the first one, but we're not done. We have to make sure it works for the second one as well. Writing down the problem first and then going ahead to plug it in. The y is 1, the x is 9. So here we have 18 equals 54 minus 36. I don't know this off the top of my head, so I'm going to do some side work. We're going to have to borrow 8. It definitely checks out, so I can confidently say that the solution to this system is indeed 9, 1. Okay, so let's go ahead and move on to the next one. So here for number 4, what I'm actually going to ask you to do first is let's take a look at what would happen if we used elimination. So here, the first one's good to go because it's already in standard form. So let's write that down. Negative 8x plus y equals 13. However, the second equation's not ready to go. We need to move over the negative 4x by doing the inverse of adding 4x to both sides. Keeping in mind that when I rewrite it down here, I do want to make sure that the x's are written first so they can line up nicely. So we're going to write 4x plus 4y equals negative 20. Okay, so now we can go ahead and get started with elimination. I think it's going to be easier actually to eliminate the x's. Why? Because there's already one that's negative and one that's positive. And the lowest common multiple between a 4 and an 8 is 8. So this one wouldn't have to change. This one would only have to change by 2. So let's go ahead and multiply that by a 2. Notice it's a positive 2. Again, why? Because there's already a negative number here and a positive number here. That's exactly what we want. So the first one's going to stay the same. We have negative 8x plus y equals 13. Now here we have a positive 8x plus 8y equals a negative 40. So now that leaves us with 9y equals a negative, let's do some side work, 40 minus 13. We're going to borrow. It's going to be 7 and a 2, so it's 9y equals negative 27. Divide both sides by 9, and I'm left with y equals negative 3. Now what we're going to do is go ahead and plug it into one of the originals. So I think I'm going to go ahead and plug it into, let's see, let's plug it into the first one. Negative 8x plus y equals 13. Here we're going to plug in the y in for only y. So we have negative 8x plus a negative 3 equals 13. We're going to get rid of the constant by adding 3 to both sides, leaving me with negative 8x equals 16. Now simply divide both sides by negative 8, and I'm left with x equals a negative 2. Now at this point, I would say that I think the solution is negative 2 comma negative 3. Why would I say that I think? Because of course we would have to check our work. Okay, so now what if instead we had the same equation but I decided to use substitution instead? What could we do? So here, all you really do is you need to make sure you isolate one of your variables. Now, typically, you would go straight for this one because you recognize it. You would go ahead and add 8x to both sides to isolate your y, giving you a y equals 8x plus 13. That's great. However, I do want to show you a different method. You can also notice here y is almost isolated. There's a 4 here, so what you could do is just divide everything by 4 and this equation would be ready to go. So let's go ahead and change this. Now the 4's cancel out, leaving me with y equals. These would also cancel out, leaving me with a negative x minus 5. So what I can do now is take this value and substitute it into y. So let's go ahead and write it down. Negative 8x plus y equals 13. I'm going to go ahead and take this value and plug it in. So now I have negative 8x plus, instead of y, I'm going to plug in my negative x minus 5 equals 13. So now, since this is just a positive number, distributing it will not matter. If it was any other number or sign, it would. So here, we're just going to go ahead and combine a negative 8x with a negative x, leaving me with negative 9x minus 5 equals 13. Simply add 5 to both sides. We have a negative 9x equals 18. Divide both sides by negative 9, and I'm left with x equals negative 2. However, we're not done. We are going to have to plug it into one of the originals. I'm going to go with the negative 8x plus y equals 13. Now we're going to go ahead and take this value for x and plug it in only for x. So we have a negative 8 times a negative 2 plus y equals 13. So here we have 16 plus y equals 13. Subtract 16 from both sides, and I'm left with y equals negative 3. So here, I'm not sure if you remember, but this is the same exact answer that we got when we used elimination. So again, it really doesn't matter which method you use. If you chose to use substitution, if you choose to use elimination, you'll still get the answer, but it's still going to be a requirement for me to make sure that you check your work, especially on your quiz. So on this particular lesson, I am going to be skipping the check. I'm hoping that you've got it by now, but if you do need reference or you do need additional help, please refer to previous lessons. Okay, so now moving on. So go ahead and pause the video and try this one on your own. You get to choose whatever method you want. It could be elimination or it could be substitution. I highly suggest that you don't choose graphing just because I'm not providing you any graph paper. So go ahead and pause the video and try this one on your own. Okay, so first I'm going to go ahead and show you what happened if you chose to use elimination. The first one's ready to go, so I'm just going to write that down. Negative x plus 5y equals 3. The second one is not, because it's not in standard form. I need to move the x over, so I'm going to subtract 2x from both sides. Making sure I do write x's first, I'm going to write negative 2x plus 2y equals a negative 10. Now here, it would be easier to eliminate the x's, so I'm going to go ahead and change the first one. Why the first one? Because the lowest common multiple between a 1 and a 2 is 2. So this has to be changed by a 2. However, since both of these signs are negative, I'm going to also have to multiply it by a negative 2 to keep one positive. So now my new equation is going to be a positive 2x minus 10y equals a negative 6. Now this first equation is going to remain the same, so we have a negative 2x plus 2y equals negative 10. So the x's cancel each other out, leaving me with negative 8y equals negative 16. Divide both sides by negative 8. The negatives cancel out, leaving me with y equals 2. But of course, you got to plug it back into one of the originals. I'm going to go with the first one, so negative x plus 5y equals 3. I'm going to go ahead and plug this y back into just the y. So we have negative x plus 5 times 2 equals 3. So negative x plus 10 equals 3. Subtract 10 from both sides. Negative x equals negative 7. Not quite done yet. Divide off that negative number. And I'm left with x equals 7. So here I would say that I think the solution is 7, 2. And the reason why I'd say think is because, of course, you need to make sure you check your work. Now, what if you didn't use elimination? What if instead you chose to use substitution? Let's go ahead and take a look at what that may look like. So here, looking at my options, again, you could choose to eliminate the x's, but you would have to make this particular x, but you would have to remember to divide everything by a negative to get rid of that sign. But again, I want to show you a different method. What you could do is to simply, since the y is almost isolated, simply divide everything by 2, and that would isolate your y. So I'm going to go ahead and keep this one the same, negative x plus 5y equals 3. This will cancel out, leaving me with y equals, let's see, that's going to be an x, and this is going to be a minus 5. So now what I could do is go ahead and take this value and substitute it in for x. So let me go ahead and write this down here. Negative x plus 5y equals 3. I'm going to take this value and substitute it in for y. Okay, because it says y equals. So here we have negative x plus 5 times, what is y? X minus 5, and then it's supposed to equal 3. So here we have negative x plus 5x, because I'm distributing, minus 25 equals 3. Combine like terms, we have 4x minus 25 equals 3. Add 25 to both sides. 4x equals 28. Simply divide both sides by 4, and we're left with x equals 7. However, we're not done. We're going to have to also solve for y. So let's go ahead and plug it into one of these. I'm going to go with the second one. So we have 2y equals 2x minus 10. What I'm going to do first is go ahead and take this value and substitute it in for x. So now we have 2y equals 2 times 7 minus 10. So we have 2y equals 14 minus 10. 2y equals 4. Simply divide both sides by 2. And we're left with y equals 2. So yet again, we get the same exact answer. The answer is still 7, 2, but this is just another method to solve it. So it's totally up to you if you feel more comfortable with substitution, if you feel more comfortable with elimination, or your mind just strictly sees substitution right away or elimination right away. Do what's best for you. Okay, so now let's go ahead and try number 6. Go ahead and pause the video and use whatever method you want to solve it. Okay, so now let's go over the answer. The first thing I'm going to do is show you what might have happened if you used elimination. So the first equation's ready to go, so I'm going to write that down. Negative 6x plus 2y equals 12. The second equation is not. I'm going to have to move my x over. So we're going to add 2x to both sides. Notice you want to make sure you write x's first. That's very important. You don't want to just automatically put 4y. Let me demonstrate for you. This is wrong, but if you put this, you're going to notice they're not going to cancel each other out, and it looks a little bizarre, so please do not do that. So the correct way would be to make sure that the x's go first. So we have 2x plus 4y equals a positive 10. So here, what could I eliminate? Well, I know that I've been eliminating the x's very often. Understand that you can choose to eliminate the y's. It's not that you always have to eliminate the x's. However, I think it's easier just because there's one that's already negative and one that's positive, and 2 can be multiplied to give me 6. So I'm going to go ahead and change the second equation by multiplying it by a 3. If you're wondering why, because the lowest common multiple between 2 and 6 is 6, so 3 is going to be multiplied by 2 to give me the 6 that I need. So the first one is staying the same, negative 6x plus 2y equals 12. Second one is going to change to a positive 6x plus 12y equals 30. Now, the x's cancel each other out, leaving me with 14y equals 42. Simply divide both sides by 14, and I'm left with y equals 3. Of course, we're not done. I'm going to plug it into one of the originals. I'm going to go ahead and choose the second equation. So we have 4y equals negative 2x plus 10. I'm going to go ahead and take this value and substitute in for y. So now I have 4 times 3 equals negative 2x plus 10. We have 12 equals negative 2x plus 10. Subtract 10 from both sides. Now we have 2 equals negative 2x. Divide both sides by negative 2. And I'm left with negative 1 equals x. Now, how would I write that as an answer? Of course, you write x's first. So I'm going to say that I think the solution is negative 1, 3. The only reason why I would say think is because, of course, I still need to check my work. Now, what if you didn't use elimination? Instead, you used substitution. What might that look like? Well, let's check it out. Here, if we wanted to use substitution, again, it's just an option. Since this is almost already isolated, what I can do is just divide everything by that 4. Okay, and then here it would leave me with y equals a negative 1/2 x plus 5/2. Now, would you want to plug that in for y? I personally would not want to. So this is not a good sign. So what could I have also done? Well, I could have also isolated one of these variables, maybe an x or a y. So let me just show you real quick. I'm not actually going to use substitution for this one, but I just want to show you. So here, if we have a negative 6x plus 2y equals 12, I'm going to isolate the variable with the smaller coefficient just because there's a less chance that I would end up with a fraction that way. So I'm going to go ahead and add 6x to both sides, leaving me with 2y equals 6x plus 12. Now I can divide everything by 2, leaving me with y equals 3x plus 6. So if I wanted to, I can go ahead and take this and plug it in. However, what I want to, I think it'd just be a lot easier to use elimination. But again, you can totally take this route. It would still give you the same exact answer. So be my guest if you feel more comfortable with substitution. Okay, so that's actually going to conclude the lesson for today. Thank you so much for tuning in. And as always, until next time, bye.